Okay, so in the last video on this topic, we talked about using our trig ratios as a means of finding sides, finding unknown sides of right angled triangles. Now, we're going to take a similar idea here, and we are going to look at the effect of finding the 3, 2, 1. So in the last video from this topic, we looked at finding unknown sides of right angled triangles, and we used this via 3, 2, 1. So in the last video from this topic, we looked at finding unknown sides of right angled triangles, and we did this using our trig ratios of sine, cos, and tan. And in this video, we're going to take a lot of those same ideas, but we're going to apply this to finding unknown angles instead of sides. So before we get into it, I will just remind you of these ratios we looked at. So we have sine theta, which corresponds to the ratio of opposite over hypotenuse. We had our cos theta, which was our adjacent over our hypotenuse, and our tan theta, which was the opposite over the adjacent. And we had this SOHCAHTOA thing that I talked about, which helped us to remember these. Now, when we approach these types of questions, in terms of finding angles, the process is very similar. We are still trying to link everything to kind of one of these, we're still trying to link this to one of these ratios here, but the actual operation we do changes a little bit. So once again, we are just going to define the key sides here. So we are looking at finding this angle here. And I've written this as theta, which is just our Greek symbol, usually to denote an angle. And we are finding this angle. So to find this angle, we need to first identify the sides that we're given in relation to our angle. And you'll see with these questions, we are given sides, two sides and an unknown angle, as opposed to a given angle and a given side in the previous videos that we did. So I'm going to identify these here. Now, my 5 in relation to my unknown angle is opposite to it, and my 8 is adjacent. So it is next to the angle. Now, in the same way, I can just write out my equation here. Well, I have an opposite and an adjacent, so I'm going to be looking at tan here. So I can write the tan of my unknown angle equals to my opposite over my adjacent. Now, what do we do here? Well, we're sort of stuck, aren't we? I don't know where to go from here. Before, when we were given a known angle and one unknown side, well, we could just rearrange this equation here to solve for that. Now, this involves another type of rearranging, but it's important for us to introduce the actual operation we're doing. And what we're doing here is called taking the inverse of this. So to remind you, well, not really remind you, but you may not have realized that this is kind of what we've been doing anytime we've solved regular equations. So taking a little pause and reflecting on the side here, if we were looking at, say, some equation, x plus 2 equals 6, We did a type of inverse operation to solve for our x here. So we identified x as being was 6 minus 2. And taking this minus 2 was almost a way of undoing the plus 2. And that is what an inverse is. An inverse is just an operation that undoes something, put in the most simple kind of terms. So we take these inverses a lot. We also did, for example, if we did say, 4 lots of x equals 8, the inverse operation was just the opposite. So you may remember when we did equations, if we wanted to undo a plus 2, we would subtract 2 from each side. To undo, say, a subtraction, we would add. To undo a division, we would multiply. And to undo a multiplication, in this case, we divide. And that is the inverse operation. So we did this to say, all right, well, x then equals 8 over 4. So we're doing this type of inverse operation here. And that is exactly the same as what we're going to do here. And there's a specific type of notation we do. Because in the end, with these questions, we're solving for this bad boy here. We are solving for theta. So what am I going to do? Well, to solve any equation, I just want this thing on its own and everything else on the other side. And there's a special operation we do, and that is called taking the inverse. So I can write this theta. Sorry, it's a different color to the one I did before. I think it was a bit darker. I can write my theta as the inverse tan, and this is written by tan to the power of -1. Sorry guys, I'm a bit sick here. We're going to take the inverse tan of 5 over 8. And you'll see on your calculators, if you have like a regular sort of scientific calculator, you'll see this button near your trig, your little trig buttons, where you'll have your sine, cos, tan, and you should see above them, you have these symbols of sine to the power of -1, cos -1, tan -1. And usually if you have a Casio calculator like mine, you can click shift and go into and shift and click on those sine operators, and that will give you your inverse. So putting that in, we get that this is equal to 32 degrees. I've just rounded this off, but that is how we solve for angles. We're doing very similar things. If you look at the actual procedure, we're identifying the angle in question. We are identifying the sides. So we have an opposite and an adjacent. And we are using one of our trig ratios here to set up an equation. And the only thing that really changes is we are invoking this inverse idea. We are taking an inverse tan, an inverse sine, an inverse cos to find an answer in degrees. Because in the end, we are solving for an angle. I'll see you guys next time.